Okay, good morning, everybody. Back at it this morning. It is the Veterans Day holiday for in November of 2020, and it's been a wild and weird year. But I'd like to say thanks and much gratitude to all the veterans out there. Lots of family and friends that have been in the services, and very much appreciated. You are the ones that made it and make it um, possible for us to do the things that we get to do in this amazing country, and I'll never apologize for that. So anyway, I was thinking today about what I might do, and to try to take to step back a little bit and think about the things that I've sort of run into as I've tried to take off on this adventure with a 62-year-old bus. And you learn a lot of things, and I've learned a lot of things, and it's been quite a challenge to dig in and find out how things work, because I had never ever worked on any type of diesel uh, vehicle or anything with air brakes and 62-year-old electronics and electrical circuits, and everything is greasy and heavy and rusted and smells funny, and it's a whole lot of fun. So anyway, I was thinking today about one of the things that I just ran into this last few couple of weeks was we got this old bus running. It runs pretty well. It needs a little bit more tweaking on the tuning on it, but I took it down the road for a ride um, last week, a couple of weeks ago, and it actually stretched its legs a little bit for a couple of miles, and it actually did really, really well. So I was real pleased with that, and my buddy Jay helped out with that, and I've had a lot of help with people who've shared their knowledge. So I was thinking about some of the things that I've had to sort of root through, one of which is um, the issue regarding uh, electrical generator, and or alternator. Now, we're not talking about the house generator sitting under the cargo bay that runs the internals of the cabin. I'm talking about the charging system that is built into the engine. And back in the early days of automotive research and development, they used a generator. And the generator, they sort of do the same thing. The generator, along with the regulator, does the same thing. They work together. The generator creates the electricity by converting the rotational motion of the engine, which is running off of diesel, into electrical energy, which can be used to go into the battery to charge the starting battery, so that the next time you come out and want to crank it, you have electricity in your battery that will provide energy to operate your starter to turn your engine over. And then there's also other things that were in vehicles, such as lights and mostly lighting inside is electrical. Diesel engines do not have an electrical system per for the ignition system. They operate only on compression and diesel fuel, and but so they don't use spark plugs, which a lot of people don't really understand that. They don't have coils and breaker points and things like that like gasoline engines do, or at least this type of two-stroke diesel does not. Um, there are some minor variations of that theme there, but anyway. Um, so what we found out last week was that this generator was not operating, and it was just dead. And it was unusual, and it was surprising to me, because it sat for about 20 years, but it had to get to the place it sat somehow, and it had to have been operative at the time to get it there. My guess is it was. I don't imagine that anybody towed it in there with a bad generator. And the lady that owned it before me did say that it had been driven to the site, and it had just been sitting for 20 years. So I did get, the engine is operative now, it just was not charging the battery. So I would have to put the charger on the battery before I could try to even hit the starter to start it. So we started looking into the theory of the generator, how it works, and how it works along with the regulator. And in a few minutes I'll show video of the generator and of the regulator and how the two communicate back and forth, and how the regulator takes that generated current off the armature of the generator. I said the regulator takes that current, and it takes it and it compares it to what the battery needs. And this is a real elementary description of it. And it says, hey, do I need to charge the battery? And if it does need to charge the battery, it says, okay, here we go, battery, here's your current. If it doesn't, if the battery's up, or if the engine is at low RPM, it goes, hey, I don't really want to generate right now. I don't want to send any current to the battery because I don't have enough current to send. So the battery will send me back current, which is the total opposite, which has other impacts inside the electrical system of the generator and the regulator together. We won't go into all of it. But I did a lot of research, and I've got a lot of experience with rotating machines and generators, electrical motors, induction motors, things. Early in my career, I did a lot of that sort of work, and I have had a lot of coursework in those devices. But it's been a long, long time, so I had to kind of scratch my head for a couple of weeks. So the first thing you got to do if you have an issue with the generator or alternator, or you're trying to go through this whole process of deciding, hey, is my generator working properly? Is it adjusted properly? If you still have one. A lot of these old buses have already been converted over to an alternator system. A lot of them still have a positive ground system, which is counterintuitive to most of us that grew up on negative ground systems. So, you know, it's the same principle, it's the same theory. You're getting to the same place. You're taking rotational motion by using the diesel engine, which is operating to create current, which goes into the battery to charge it up so that at some point in the future, later on when you need it, you have current to convert back the mechanical energy to turn the engine over. And that's the way that works. So there's a series of GM manuals out there. One is a operating manual, one is a maintenance manual, and one is a parts manual. And they're available online. Don't go pay money for them. You can find them online. This is 60-something-year-old, information that was, when I was born, was out there. So don't go pay $20 or $30 for it. I know there are people that sell it on eBay, and hey, good for them. But, if somebody wants a bound book that looks like one, fine. You can get them electronically and download them in 5 minutes. And any of us can shoot you a link to where you can find it. The books are, the operator's manual is pretty cool because it just says, hey, this is how you drive a bus, this is how you operate, this is how you open the cargo doors, this is where the this is where the battery compartment is, this is how the brakes work, this is how you shift to reverse, which was an interesting process, experience for me. The other thing, the other ones, like the maintenance manual, is really more. It's not what probably the factory guys would have had, or what the repair guys in the repair shops would have had. They probably would have had like the next level, but this is really good information. And then the parts manual is helpful because it has blow-ups of the major components. And there was one issue with mine that I had a hard time figuring out, and I finally had to dig into the parts manual. And I went way, way, way down into one of the parts manuals, looked down at the parts list, cross-referenced back to the drawing, cross-referenced back to some stuff in the maintenance manual, and I went, well, there's actually a mistake in the parts manual. Once I figured that out, and put two and two together, it began to make total sense. So that's kind of where I am, and I think what I'll do, and this is the manual here. Now what I did, and go ahead and go to Kinko if you got a good printer or whatever, got access to a good printer, go ahead and do it. But you can get an entire section on electrical system, okay? There's, 8 or 9 sections. The manual is probably this thick right here, at least. And you can make notes in it, because what'll happen is, I promise you, if you fix it today and you have to dig back into it for some reason in a couple of weeks or a couple of months or a couple of years, you won't remember all this. You don't have to go back and remember it. So make notes in the margins. Hang on to that. I'm an old dinosaur. I like paper, and I like to make notes, and I like 3-ring binders. I've got 3-ring binders all over my office and all over my house for that reason. But so I would go with that. There's lots of help online, lots of help on the Facebook 4104 group and Vintage Bus Mechanics group. There's a lot of us that are happy. If you're interested, if you need, if we can help shorten your journey, reach out on Messenger or something. I don't care. I'm happy to talk to people. I've had about a half a dozen people on the Facebook group that have really been generous with their time and their phone calls at night and their stuff that they sent me, and I greatly appreciate that. Okay, so that's the kind of the long intro, and I'll go into this just enough that it will help somebody get enough information in their hip pocket and be able to do further research. Okay, I'm not going to try to go into it and dig so deep into it in this video, but I'm happy to try to share what I can. And the disclaimer here is I'm not a factory trained mechanic, and I'm not 100 years old and have worked on these things. So anything you do is on you. We're all in this, and we're all mechanics and technical by nature to some degree. And anytime you open up a cargo door, or you open up a bay door, or you open up the engine hatch and you start fiddling around with anything, you run the risk of something not going well. So, if you do something I do or something I've said here, yeah, it's on you. So, okay. All right, so here's what I'm going to do. I'm just going to show a brief kind of tour of the generator, where the generator is located, how it works, where the voltage regulator is located, and I've got the covers off of all of that, so that you don't have to sit here and watch me undo screws and all. The theory's really simple. The alternator system, which a lot of people have gone to, is the same principle, basic principle. There are some variations in the type of current, i.e. voltage, voltage, i.e. current, that is generated back to the regulator, because the alternator doesn't have an external regulator. It basically regulates it on the inside of the alternator. So, and the way it generates is a little bit different. I won't go into all of that. So, anyway, we'll go ahead and do this, and hope you guys get something out of it, and be happy to help if I can. Okay. All right, here we go. Okay, so here's Wonder Dog. Wonder Dog is starting to shape up. I won't go into all of the progress that we've made, but I've had a lot of good help, and I appreciate it. Okay, right here on the rear of the engine, that big device right here is the transmission, for those of you that aren't familiar with it. That's a reverse solenoid that lets you put the transmission in reverse. All right, this is the generator. Now, right now the cover's off of it. You won't see all of this internal stuff. Okay, these are the brushes, and those brushes ride on a commutator. And commutator is built into the rotor, and the rotor is a big bundle of wires all wound up around cores on the inside, and it's turning direct drive off of the engine. So the way you make power in any, the very, 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 very basic cardinal points of generating electricity is you have to have a magnetic field, and you move a wire through it. Any physics book will show you that, back to the 8th grade. So the way they do this is they take the rotational motion off the engine. There's bundled wires that are coiled up in there, in the armature way down inside, right in there. It goes round and round and round and round and round. And on the outside, in here, it's like a donut in there. On the outside of the donut is a series of coils. And the way you would do it with a true induction system would be to move the wire through a magnetic field. Well, magnets weigh an awful lot, and they'd be enormous. Okay, so what they do is you use current flow back from the regulator to this field winding right here. That's your field terminal. Okay, current goes through those coils that are mounted on the inside of that armature case, the generator casing, and that inside rotating machine in there that has the bundled wires on it have these little brushes, and they're not brushes like you think. They're little pieces of carbon blocks that ride on a commutator, which is a series of little contact points around a smaller disc on the not disc, but a cylinder on the inside. So as it turns, it's always providing magnetic field to this terminal, and at the same time it's inducing, because of the rotational motion, it's inducing current in the armature. These brushes pick it up. They collect all that current that's coming. There's 3 sets of poles in here. That current's picked up from this terminal here, and it goes right back up here through those wires, right down through here. There's your armature current. That's your charging current going down to there. Well, what are these 2 wires? Well, you got to get some kind of a voltage back to the field terminal, the first one, to provide the magnetic field. That's one of these. I don't know which one it is right now. The other one is this terminal right here, which is your ground terminal. And the ground terminal, because this device is working with the regulator, which is in here, they have to speak the same language and be